This is A2Pure, and we're taking a look then at the modulus function. So the modulus function, f of x equals the modulus of x reflects negative values into their positive equivalent. So it's defined by f of x equals x for all x greater than or equal to 0, and f of x equals minus x for all x less than 0. That looks a little bit more complicated than it actually is. All it does is change any negative to a positive. It's always the absolute value or the positive value that we're looking for. To obtain the graph of y equals the modulus of x, first sketch the graph of y equals x. So that's it going down here with the dotted line going across here. The parts of the graph for which y is positive are kept, and the parts of the graph for which y is negative, that's this bit here, are reflected in the x-axis. So it goes up like that. So the graph of y equals the modulus of x then looks like this here. So this bit here has been reflected up here. So it just makes everything positive. Let's look at a few other graphs then and see what we end up with. So our first one is y equals the modulus of x plus 3. So the way we normally set this up is to draw the graph of y equals x plus 3. That's what I'm going to do here. Nice straightforward one. So this one crosses at 3 with a gradient of 1. So I'm going to put my 3 here. And then a gradient of 1 means it's going to cross in round about here as well. So that's the graph of y equals x plus 3. And so what we're going to do then is reflect anything below the x-axis up above the x-axis. Try and get it looking vaguely similar here. And then we shoot our 45 degrees, so that looks okay. So we then have something like that. So that's the point minus 3, and that's the point 3, and that's it reflected up then from there. Next one, y equals 2x plus 1. So again, a reasonably familiar graph we should have. So it's y, sorry, the modulus of 2x plus 1. So we'll draw y equals 2x plus 1. This one crosses at 1 with a gradient of 2. So this one's a bit steeper. We'll draw something like that, and then that's going to cross there where x is minus a half. So that's my graph of y equals 2x plus 1, and then I'm going to be reflecting that one up. So how's that going to look? Again, try and draw a similar graph. Going from here. And then that reflects up. So something like that is our graph of y equals the modulus of 2x plus 1. Finally, then we have one of y equals 3 minus 2x. So let's move the paper up a bit, sorry. Hopefully you can see that now. So that one crosses at 3 and a gradient of minus 2. So we're going down a little bit steeper, and it's going to cross in at 1.5, I think. And hopefully that makes sense. So our regular graph would look like this. That's of course the graph of y equals 3 minus 2x. So gradient of minus 2 across, 1 down, 2, etc. And a y-intercept then of 3. And then the modulus of that is going to reflect everything up from below the x-axis to above the x-axis. Again, we're doing a sketch of the graph, so we should expect a couple of points in there. I haven't done them in the previous one. Actually, let's do that. So I think that's minus a half there, and I think we were crossing at 1 up there. This one here we are crossing at 3, and then that point there is 3 over 2 or 1.5, I think, and that's the graph of y equals the modulus of 3 minus 2x.